class. This time let us study conic sections. So we have 4 conic sections, namely circle, parabola, ellipse, and hyperbola. But let this video show you first the figures of the different conic sections.
When a straight line intersects a vertical line at a fixed point and rotates about that fixed point, the surface obtained is called a double right circular cone. A double right circular cone consists of 2 cones joined at a fixed point called the vertex. The line that rotates about the vertex is called the generator, and the line that remains fixed is called the axis. A right circular cone has a circular base, and its axis is always perpendicular line from the center of the base to the vertex. The perimeter of the base is called the directrix. The lateral surface of a right circular cone is called a nap. A double right circular cone has 2 naps. The nap above the vertex is called the upper nap, and that below the vertex is called the lower nap. Also, the angle between the generator and the axis is called the vertex angle. Conic sections. If a plane intersects a double right circular cone, we get 2-dimensional curves of different types. These curves are called conic sections. Depending on the angle made by the plane with the vertical axis of the cone, ellipse. When the plane intersects the double right circular cone in such a way that the angle between the plane and the axis is greater than the vertex angle, we get a closed curve called an ellipse. When the plane is perpendicular to the axis, the ellipse becomes a circle. Thus, a circle is a special type of ellipse. Parabola. When the angle made by the plane to the vertical axis is exactly equal to the vertex angle, we get an open curve called a parabola at the intersecting surface of the cone. Hyperbola. The plane intersects only one nap of the double right circular cone as long as the angle between the plane and the vertical axis is greater than or equal to the vertex angle. However, if the plane intersects the vertical axis at an angle smaller than the vertex angle, the plane intersects both the naps of the cone to form an open curve called a hyperbola, which has 2 disjoint curves.
So these are the different conic sections. So the general form of a kind is ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. But we are only going to focus on ax squared and cy squared, or in our a and c. So if a is equal to c, or the value of the coefficient a is equal to the value of the coefficient c, then that equation forms a circle. If a is equal to 0 or c is equal to 0, but not both of them are equal to 0, or shall I say, if either ax squared or cy squared is missing, then that equation forms a parabola. If a and c have different coefficients that same in sign, meaning they are both positive or negative, then that equation forms an ellipse. And if A and C have different signs, meaning one of them are positive and the other is negative, then that equation forms a hyperbola. Okay, so let us try to classify these equations. So the equation must satisfy one of the definition in our guide in order to determine if that is a circle, parabola, ellipse, or hyperbola. So we have to observe first these equations before looking in our guide in order to classify these equations properly. So let us start with letter A. In letter A, we notice that our coefficients in x squared and y squared, which is our A and C, are the same. We have the coefficient 3. So in our guide, if we are going to look for that definition, if A is equal to C, meaning the coefficient of x squared and y squared, which is our A and C, are the same in our first example. So we have 3. So meaning that equation forms a circle. In letter B, our equation is 6x squared plus 12x minus y plus 15 is equal to 0. So we notice that ax squared exists, but cy squared does not exist. So meaning our cy squared is 0. And if we are going to look for our guide, so which of this definition satisfied? So that is the second one. And it says here that if A is equal to 0 or C is equal to 0 but not the same, equal to 0, that is a parabola. In letter C, our equation is x squared plus 2y squared plus 4x plus 2y minus 27 is equal to 0. But we notice that A and C are not the same, or the coefficients of x squared and y squared are not the same, but still they have the same sign, which is positive, because we have positive x squared and positive 2y squared. So which do you think of this definition was satisfied? So in our guide, the third one, it says there that if A and C have different numbers or have different values but the same in sign, then that forms an ellipse. Okay, so next in letter D, we have x squared minus y squared plus 3x minus 2y minus 43 is equal to 0. So we notice that we have positive x squared and negative y squared, though they have the same coefficient, which is 1. Which do you think does this satisfies? In our guide, in the fourth one, if A and C have different signs, then that is already a hyperbola. Okay, so sample letter D is an equation that forms a hyperbola. So lastly, we have example letter E, 9x squared minus 4y squared minus 54x plus 32y minus 19 is equal to 0. So we noticed here that, again, their signs are not the same because we have positive 9x squared and negative 4y squared. And it was said a while back that if A and C have different signs, then that equation forms Very good. Still, that is a hyperbola. So that is all for the classification of conic sections. Now it's your turn to classify these given equations using the guide.